Well, welcome to another community meetup. I was talking to Andrew this week. He had a big week. Andrew just crushing it out there. Same with you, Eric. All of you, continue to push the mark forward with refrigeration and helping your customers out. I'd love to dive into a little bit on Andrew this week that we had a few chats on how you're helping some people on your team. Now you're like full EMS, but also you were mentioned to me that you're down a guy right now, or you're going to be down a guy. So there's a lot more work put on the team's plate, which is happening more and more that I see out there. You know what I mean? There's lots of people shifting roles, or moving up, or actually leaving the industry. But I'd love to dive into that because I think that's an important thing. I talk with a lot of technicians where they kind of get frustrated that we're down men, and then they're like on the management team being like, well, we need more people. And they're like, well, we're trying to find people, but we can't find people. You know what I mean? And this is not only here, this is a global thing. I'd love to dive into some of that, Andrew.
Yeah, that's just what the industry is. We all know that we're having a shortage of technicians out here in the field, and it's just going to become more and more known, I guess, for that. And it's really up to the people that have been in the trade needs to, I feel like, that's my opinion, step in and mentor, and be that person for the younger people, or I shouldn't say younger, just the individuals coming into this trade, right? Because a lot where I came from, I didn't feel like I had that huge amount of support. So I was struggling. I felt like when I very first started in this trade, and then I had no one I felt like I could just lean on when it come down to these problems or situations. And then when I did get into a situation where I had no other choice to call, it seems like I was bothering them. And I'm like, that is not my intent. I just want to know what's going on because I want to do the best I can, and I can't. And now I'm bothering you, and I can tell you don't want to answer. So just getting the support system in the trades, which I know that's where we're leaning towards, and that's where we're headed. But I just want to put another high spotlight on that and just say, like, that is the key to success as far as where this industry is going to be going.
Yeah, I don't think that's anything different than kind of the way I started in. I felt there was a lot of struggles. There's a lot of, well, just go check it out and figure it out. And then, a phone call away, but phone call away can be tough. You know what I mean? And it depends who you're phone calling to as well. There's lots of situations. There's lots of situations we're going to get into over the next few years where it's going to be tough on lead technicians. But like you said, I think we need to train more, help share that knowledge, teach people faster. And a lot of people say, well, you can't learn supermarket refrigeration fast. Well, yes, you can learn it way faster than 30 years ago. I'll tell you that right now. It doesn't matter what anybody says. You can learn refrigeration way faster now than 30 years ago. It all depends if you want to, because there was no videos, there was no YouTubes, there was no access to experts as easy it is today. Like even the manufacturer information was hard to get, unless you knew someone or you were part of RS, ES, things like that, which is not as prevalent as it was 30 years. That was the only way you were getting like information from some of these associations and from the manufacturers. But now there's easier access to that information. But how do we help the people that are coming in as an industry together? That's the big thing.
Yeah, exactly. I mean, that is going to help technicians just stay in the trade, because back when I first started, I went through a college, went through a trade school in 2 years, and then got out and into the trade and started working. I bet you there's only 5 of us in that group of 28 that went through that are still doing anything refrigeration related. And it could be HVAC, refrigeration, doesn't matter, but just in that scope of work. And I do believe and I've gone through and seen coming through the trade where a lot of people leave because they don't have that support. And I think we are better together, hands down, and that's how we're going to really move. And that's what we're doing here at Refrigeration Mentor, is building a group of people that love the industry, want to help, and we are here for you guys. And I think that's so awesome. I'm so glad to be a part of that because that's exactly what we need here, and that's what we're doing. So I'm just excited to see where this is all gonna, where this is headed, where it's going, and yeah.
I think that that's something interesting what you said there, that there's only, 5 of you of 28 still in the industry. And when I talk to some experienced technicians who've been doing it for 20 or 30 years, or I had to do a podcast with one or get to know one of the things that they tell me, and these older guys that are still in the industry, they said, I had these great mentors. I had these great people helping me along the way. And that's usually those guys that are in it for 30 or 40 years. That every time I actually, when I talk to them, when I think about it right now, it's like they had people supporting them along the way. And I think that you're right, where a lot of people get out is where there is no support. They feel like, because it can be a lonely job. We're by ourselves in a van for 12 hours a day, 7 days a week, 365 days a year sometimes, you know what I mean? So it can get that you feel like you're isolated. But those older technicians or more experienced technicians, they felt supported. And I think that's something that that's something that we're really trying to do here. Erik, you're on a totally different continent than us. Is it much different in the other parts of the world that you go? And I talk to lots of different people, but what have you seen, and what do you think we need to do as an industry to really help the next generation?
Yeah, we see the same trend over here, that the number of people getting trained for trade schools and everything, and apprenticeships are less than people leaving the trade.
Yeah.
Again, because we have really big generations now getting older, and of course they can't be replenished, or they can't be replaced easily. So we have to train more people than we actually have the capacity to do at the moment. So that's one issue. But what I see over here on our side is that the companies are much more like a unit. So you're not a service guy here and a service guy over here, but the companies are more like a unit, and people often go out in teams. Of course, you can have your emergency calls. You always go out one guy, check out the store, what's going on. But when you build new stores and do maintenance and stuff like that, usually you have a guy and maybe an apprentice with you, and if it's a bigger job, you maybe have 1, 2, 3 guys doing the job, and that makes up for that loneliness. You get some sparring with your colleagues, and that's really, really important.
Yeah, I think that's one of the big things, is where I learned a lot of the stuff, even though the technicians that I was working with were only a year or two. Some of them were only a year or two in the trade, or maybe 3 years. It wasn't like they were 15 or 20 years in the trade, and we were learning together. But I think a lot of that conversation was what really helped, having those conversations. So and it's going to be different for people that do install versus service versus startup, because there's different dynamics. When I was coming up in the trade, it was like I was doing install, so we were putting the boxes together, we were putting the keys together, we were piping it, we were pulling all the wires, we were starting it up. You know what I mean? Then we were going to check all the TX valves, we were checking all the EPRs. So we were doing the full thing, where over the last 10 years, I don't know if it's 10 years, but I'm seeing like one company will come in, they'll build all the boxes. Another, like, laborers will come in and they'll lay down all the cases. Then you'll have the company come in and do piping. And then you'll have another company doing startup. And I think this is how stores run into big issues. You know what I mean? You got a lot of hands in the pot. And when something goes wrong, it's not as a team effort. It's like pointing fingers. I hear it all the time. It's like, well, this wasn't done right, or this was put in the wrong place, or So that's one of the things, and this not only on the technician side or the contractor side. This could be because of the end user. It could be because of the designers or the engineering firm. We need to really share that knowledge and pass that knowledge down. When I was working at Copeland, I've seen a lot of knowledge just go away. Like that was one of the things. Like I've seen all these, and this is happening in our industry right now, where someone was there for 30, 35 years. They built up all this knowledge and all this stuff, and then they just retired. There was nobody shadowing them. You know what I mean? There was no one like by their side, like an apprentice, trying to learn all that knowledge to try to get. I did it. You know what I mean? It wasn't part of my job, but I would spend that extra time with them if they were willing to talk to me. You know, and they were really good about this. Though a lot of the older technician or older people in the industry, they want to share that knowledge. They like giving out that knowledge. So most of them anyway, that I know in the refrigeration industry, they want to share that knowledge. So it hopefully will help down the road, because they took 30 years to gain all this knowledge. So how can we get that knowledge and share it out? And I've seen a lot of, and it's not only at Copeland, I heard about it at Sporlin and Danfoss and all these other big companies. It's just because as they start to evolve, things go faster and faster, and we need to fill these other roles, and it's hard to get people in the refrigeration industry. So not only for contractors, same things for manufacturers, and then all these roles, other companies like Amazons and things like that are trying to hire people for those roles, and the Googles of the world and the Facebooks are trying to hire the people too, right out of school. So there's a big challenge in it. So it's like, for me, it's like, how do we make this sexy or exciting or fun for people to come into the industry?
Yeah, that's a big question. Sorry, Andrew, but I think one of the big issues is that refrigeration is not really sexy in the public. You got your electricians and your carpenters or whatever. You always see them in movies. You see people, working with their hands in movies and in the public, but you never see a refrigeration guy.
Yeah.
And not to pat our own shoulders, but we are really highly specialized craftsmen. We could do pipe work. We can do electricity. We could do mechanical constructions. We could fault seeking. We can do a lot of things. It's highly, highly specialized, but it's not really, out there.
Yeah.
Yeah, we're the jack of all trades, I feel like, which is fun. I mean, not saying we're the best, but
no, but not at all. But it's a highly specialized job, actually, and you'd have to have a really broad knowledge about things, about mechanics, about electronics, about control systems, and just how buildings work.
Yeah. Well, I'll give you an example. I'll give you an example about this morning. I went to the gym at like 5. I got back from the gym maybe 5:30. Got back from the gym this morning around 7, and I walk in the house and I'm like, it's cold in here. And then I looked at my thermostat. My thermostat said it was calling, and it's set for 69, I think, Fahrenheit, and it was 66, 65. I'm like, it's calling, but I'm way off on temperature. What's going on here? So I knew right off the bat the furnace wasn't running. So I went downstairs and I pulled out the board. So it powered off, and I'm like, because when you pull it off, the door switch opens. So I closed the door switch and I looked at the board, and the board came up. It was a 44 code. It said low pressure switch, inducer fan not running. So I just held it in, and then I touched the little dial, and the inducer fan wasn't running. I'm like, okay, so either the fan's out or the capacitor's done. That's why the low pressure switch wasn't making. So I went and grabbed my meter, went back downstairs, pulled the plug off, and just ohmed out the inducer fan motor. Well, I was getting the right single phase, so I was getting the right ohmage. I don't know exactly what it should be, but at 90, 50, and 40, you know what I mean? So it sounds close to right. And then I checked the capacitor, and the capacitor said 0, you know what I mean? But it was still plugged in, you know what I mean? So then I unplugged it and I put it down, and it didn't say anything. Then I moved the meter around. Then all of a sudden it said I got my 6 microfarads. So I plugged it back in and then turned it on, and it ran. So I'm assuming that it's the capacitor. So my house is heated right now. It's cold here. It's like 0 degrees Celsius, so 32. But because of refrigeration, I can do that stuff. Now I'm going to order up a capacitor and see if it's that, but that's what our skill can do very quickly. Save me a $400 technician call out or $300 technician call out.
Yeah, absolutely. Just to trend back to the industry and people, as far as new techs go into the industry, I think it's important for them to kind of push towards a mentor too, because if you're just kind of if you just kind of isolate yourself, I know that's part of this trade because we're always working by ourselves, moving from the next job to the next job. It's kind of easy to do that. So you have to kind of reach out but not find that person that's willing to help you too. And that could be taking him out to lunch every so often and just picking his brain or whatever it may be. But you have to kind of be a little self-motivated to go out there and find that mentor to help you out too. And also the tough thing to ask too is once you get into a situation, sometimes you don't even know what to ask. So doing a little bit of your self research on the issues that you got going on or the problems or whatever piece you're working on goes a long ways too. So I've always said 15 minutes a day on a new component or something that you're working on goes so far as your own personal knowledge. And then that's just going to help you know what to ask when you get in those situations.
Yeah, and equally important to recognize that you do not know everything.
Yeah.
So
it does take time. You know, you can learn a lot faster. To know everything, it's just too much. And then, you know, I listen to a lot of AI stuff now and just trying to learn and develop my AI skills. And how is it speeding up past us and past what we know? Is like, I use AI a lot now. Like Andrew, you're starting to use it more and more. You say, you know what I mean? How it helps you. Just if you have a controls question or if you have a question on how to solve a problem, it's not going to give you the answer all the time. And it might point you in the wrong direction sometimes, but as it gets better and better, it's going to help us. I think one of the things is that as we continue on and evolve in industry, I'm hoping, and I think it is, we're going to make it easier for the next generation. And I talk to some people, well, it's good for them to struggle. You know, the newer guys, it's good for them to run in. It sucked. I hated it. I hated coming home and laying in bed with my wife and being like, I don't know if I fixed the problem. I don't know if that food is going to go bad. You know, I don't know if I'm going to have to get called back out in 2 hours for that same. And that's one of the things that sucked for me. And one of the things was because I just didn't know. I didn't know the questions to ask sometimes. I, you know, change parts to, well, it could be this part without actually knowing the root cause or why something happened. And that really comes back to really understanding a system. How is a system supposed to work? You know, like we talk about in our supermarket and our CO2 programs, Andrew, is that you really need to understand how it's supposed to work to be able to troubleshoot. And I think that's one of the big things is where people get frustrated or maybe even don't want to do it, like, are not interested in it, is because they go in and they don't know what to do, where to start. And it's hard. People are being thrown to the wolves, per se.
Yeah, I've seen that happen where they don't know exactly what to do. And that's, unfortunately, I think that's going to happen a lot here in the next coming years because we need people and we got all these issues, but there needs to be guidance. There needs to be some sort of training involved. Because, like you said, there's just so much to learn. You can't just say, "Here, go fix that," and then expect them to fix it without any support or guidance or whatever. So, yeah, no, it's super important to have that, and I'm seeing it now. So,
yeah. I think it's going to be good though. I think we're going to help the industry. I see more and more people that I connect with really want to help the next generation. And I don't mean by age. I just mean by people coming in. I see a lot of people older coming into our industry, which is which is helpful. This, depending on what side of the industry you're in, refrigeration it can be hard on the body. It's long hours, it's heavy equipment. But if you're smart about it, kind of like you, Andrew, you sent me some pictures there a few weeks ago, and you guys did a couple of 6D or 6-cylinder compressor, 4 and 6-cylinder compressor.
Yeah.
I used to lift that with another guy. You know what I mean? Like 300-pound compressors, us on both sides trying to carry this stuff up a stair. You know, it was crazy stuff where didn't know the difference. Where now, if we can teach them how to work a lot smarter, where you're like, here, I got this chain hoist, and I'm doing it with all devices. Where, man, there was lots of times that I didn't really know the difference. I would just slug away because I was young, you know, and we'll push this whole lineup. You know, I seen a guy push a whole lineup of cases, probably like 20 doors, and he sat and he did like a leg press against the wall and pushed the whole. I'm like, what are we doing? And then you know, no wonder like our back is going in our knees and stuff. But if we understand how to do it right, you know, use the proper ladders at the time and lifts and things like that, where it'll make us last longer in the industry. Because I think that's one of the things that worries me for the newer people. A lot of people get hurt because it's an industry where you can get hurt. And it's about safety now for me. It's just teaching the people that the mistakes I made so they don't do it, especially in the training program. They do it all, talk about it all the time. Like, and I didn't work on CO2 when I was a technician in the field. I've worked on lots of them afterwards, you know what I mean? Have the trainers and pulling out oil separator filters and liquid line filters and changing valves and stuff like that. But I wasn't actually doing it as a service thing. I was just doing it as a trainer and building lab equipment and stuff like that. And so I got a lot of experience there working with technicians. So getting with the higher pressures, we need to be safe about it. And as we continue to evolve with CO2, it doesn't matter if it's a higher pressures. You drive down the highway in a car at 100 miles an hour is way more dangerous than a CO2 system you're going to work on. You know what I mean? But people do that every day. Oh, I'm on the highway. And that's it. So it's learning, helping, teaching, and educating the new people coming in. And how do we do that faster? This is what every refrigeration business is looking at. How do we train these people faster?
No, exactly. And then just going back to this industry where you can get hurt. Yeah, when I was younger, I just grabbed those compressors and hiked them up the stairs or whatever it needed to be, out of the van, into the van. Really, it took me a huge accident. I ended up getting in a car wreck, hurting my back, actually broke my back. And now I'm super careful with it. So now I actually think about how I'm going to lift all these components, because now that my back is damaged, so I have to think outside the box. And looking back, I wish I took the extra 10 minutes to set up that chain hoist versus just, muscling it into position. It would have saved me a lot of back pain before my back even was broken. So it's one of those things that, but if you don't stop and think about how you're going to get this compressor where it needs to be, or maybe this week I had to change out a huge hot water tank, heat reclaim water tank. And I had an apprentice with me. So I showed him all the mechanical advantages we can do without just fully muscling it into place, and asking for help too when we have to load it into a van or whatever we needed to do. It's amazing, like, because I would just say, oh, we don't need anybody. Just, when you're younger, you think you're Superman. I'm guilty of it, and I wish I never did.
Yeah, I agree with you that I think the more we, I guess, as experience, the more we learn, the more we want to protect ourselves, right? Because this is a long career. It is, and I think if technicians, like, just teaching them, like, younger people coming in, because I have a lot of people in their early 20s coming into like the supermarket academy and the supermarket programs. I think one of the things is that there's so many options that you can do in refrigeration. Not, you can do construction, you can do install, you can do service, you can do sales, you can do project management, you can do service manager, director. There's so many roles, EMS, like controls. There's so many different roles. But I think it's that the first year, for me anyways, the first year, getting that experience right off the bat, making some good money, putting the hours in, and then teaching other people along the way. You know what I mean? Like a lot of people say, well, I only been doing it for a year, Trevor. You know what I mean? Like I don't have anything to share. Yes, you do. Do you know what a set of gauges are? You know what I mean? Like that's something more than someone who just started that day and they were working on direct TV the day before. You know what I mean? Like I know here in Canada, it's a little different than in the US and in different countries with apprenticeship programs and things like that. But I think it goes a long way just showing little tips and tricks that you do all the time, Andrew. And same with you, Erik. I know you're doing a startup now. You know what I mean? I'm sure the contractors there and you're teaching them. You know what I mean? And we haven't even talked about it, but I bet you, like we talked about it many times before. It's like you're trying to share that knowledge. You know what I mean? Because when you leave there, you're not coming back. Like you don't want to be coming back. You want them to be able to be successful and setting them up for success. And I think that's what we need to do in the industry.
That's the whole point of what we do here. That's when I go on a commission, I technically don't do any work. It's a hands in the pocket kind of thing. So I teach the guys on site how to commission their own system, or in this case, my system. But they own the system. It is their system, and they need to know how to operate it, how to commission it, how to service it, how to tune it in and decommission it when that time comes. So all these things we go through with the customer on site with his technicians and with his maintenance guys and his service guys and installers. So as many people the customer could get on site and I can train, the better, because the next time they buy a unit, they know maybe 80% of all the things you need to do, and then they only have to call me for the last 20% on the phone. They could make it as phone support instead. I have to travel out there.
Yeah. What do you think the biggest learning curve is for them? Because you've done this for a long time. What do you think is the biggest learning curve when they send out technicians? Because I know for sure it's not all the time that you're getting the most experienced guys. You know what I mean?
No, you're getting a big variety of guys. Of course, all the new guys coming from school, everything, they have a basic knowledge of the advanced CO2 systems and new controllers and all that stuff. At least over here, they learn it in school, how to do all that. But still, there's a long way from learning about it in school and actually using it on your own. So I think the biggest hurdle is maybe being a little bit afraid of doing something wrong. So
yeah.
and basically these systems, unless you physically cut the high pressure pipes, it won't bite you, right? So you can do a lot of things. You could really do a lot of tweaking and everything, and go down a rabbit hole you should never have started on. But you won't damage the system as such. It will just stop working, and then you just have to find your way back again. So just have the courage to do things. That's maybe the biggest step. And then, of course, look through the fact that yes, this is high pressure. It potentially has a lot of energy that can be released, but all the components are dimensioned for it. So why worry about it? If you're really worried about the high pressure gauges, I usually say to people, just place your thumb over the last digit, and then you're back to normal pressures, right? So yeah. There's nothing different. It is a refrigeration system, right? It's the same components. You got compressors, you got whatever, and then you just have the courage to start working on it.
And we're talking about this now in like 10 or 15 years. Like it's going to be normal because it'll be in the school systems more, and they'll be seeing just those. And that's the differences between, I see different countries around the world. Some countries don't even have CO2 yet, and some countries have lots of CO2, and some countries that's all they have. depending on where you're at in the world. But I think it's still just a refrigeration system. You have to know your safeties. Electrical, like that is dangerous. Refrigerants, it's dangerous.
It's the same as driving a race car.
Yeah.
You can drive a race car super safe if you know how to operate it.
Yeah. And it's
those guys they know exactly how far you can go, how far you can push that car. But if I went into a race car, I'd probably crash it in the first 5 laps or something.
And that's fair. And the big thing is like for those listening out there, you're probably in the field already and you're a technician. But I would highly recommend talk about this with other technicians, or talk about how you are going to share your knowledge with someone. And that goes a long way. You may not think about it, even if you're doing it for a couple of years, you're only 2 years in. That, like I said earlier, that knowledge that you can pass on to someone, or talk about what you like about the trade. Because every job, there's going to be stuff that you don't like. I don't, because I see it online. I read lots of these posts, why supermarket refrigeration is the worst thing and all this stuff. But you go be a midnight custodian, could be the worst job in the world, but that could be a great job too. You know what I mean? There's lots of benefits of it. You know what I mean? So, or sitting at a desk, there's lots of benefits of doing your 9 to 5 at a desk, but there's a lot of things that are not great about it. You know what I mean? So there's trade-offs for every role that's out there. It's like, how do you, do the things that make it worth it, and I think that's what refrigeration is. You can make lots of money, you can travel around the world. Like Andrew lived in multiple places. Erik travels all around the world doing startups. So these are the things that you can benefit. Sometimes there are sacrifices in every role, every job, but I think refrigeration is one that could really benefit, especially if you get into it early enough. Like I started 24, I think. That's when I got into refrigeration. But I see a lot of people I meet, it was like, well, it was through my uncle, or it was my dad, or I started when I was like 18 through a friend, and it was neighbor knew refrigeration. Like Erik said earlier, nobody knows what refrigeration is. Like I ask people all the time, and like I'm in refrigeration. But I was surprised. So at Thanksgiving, I was at a turkey dinner. It was a fundraiser, and one of the ladies that was serving the food, she seen my shirt and my sweater, and it said refrigeration mentor. She's like, "You're in refrigeration? My husband did it for 30 years and he loved it, and it helped our family and our kids." And I'm like, you get me. And the lady was probably like 75, 80 years old. And I'm like, that is awesome. That is awesome. Okay, let's get into some technical stuff. So if any of you are like interested in getting into, learning about supermarket refrigeration, get into the community, refrigerationmentor.com/hub, if you're listening to this or watching this, because this is what we're trying to do. We're trying to help fast track your knowledge, help fast track you feel comfortable so you're not stressed out. But I want to dive into some technical stuff now, and Erik, you'll probably have some good stuff to share with this. But over the last couple of years, I've been doing lots of CO2 trainings and reading a lot of the manuals, and like from Advancer and from all the other manufacturers in their literature, or Bitzer or Copeland or Doran, in their literature talks about oils, and what type of oils are supposed to be in compressors, HFC versus CO2, the different viscosity of it. So I got over like a lot of the courses. I'll tell technicians about doing a lab analysis versus just an acid test or acidity test. And a lot of them will send me their analysis and ask me, like, how do I read this? You know what I mean? Because I didn't really know how to read. I'll be honest with you. I didn't know how to read it until I was taught, and I'm still learning how to read it. So I reached out to my friend Giacomo Pisano from Doran, and I was like, can you walk me through this? So he sent me an email. He's such a great guy. He always helps me out when I ask for questions or ask him questions. But he sent me this one from Reniso, Reniso. It's kind of like their oils chart. There's many different oils out there, but this was one of their charts for their mineral oils and their alkabenzes or their esters, like the POEs and PEG oils. And so if you're watching this now, you can see it on the screen. But if you're listening, there's different information on here. So I appreciate it. And maybe different manufacturer oils will have a little bit differences. But if you look on here, you'll see that you got a water content, maximum water content in this area right here. Okay. So when I worked at Copeland, that was a big thing. And you'll see, and when you look at Sporland's information or Bitzer information, it's like, how much moisture can we get out of that system or out of that oil so we don't have water or moisture in the system? And Andrew, why is moisture bad in the system?
It just creates havoc everywhere, not just the compressors, but it could be at your metering devices. It could be at the drop leg where it pees up and it gets trapped in the P trap. So then all of a sudden the whole circuit stops working. I mean, it creates so much issues outside of where just the compressor's at, even at the compressor, it could destroy your compressor in a hurry. And that's why we do the analysis and check to see what's going on with that compressor. Why? The biggest question when you have your compressor that fails is why. And knowing where the steps to go to figure out that why is key. And this is one of them.
Yeah. And the compressor is usually the most expensive component out of all the components in a system, because like in a gas cooler, it'd be the condenser fan, like that would fail. Like, we're not talking about the whole thing, but that compressor is usually the most expensive component. And so if we get moisture in that oil, we'll start to break down the windings, for an example. But you had a great point there. Like, if you get moisture in the system, it could freeze up in the EEV, or you have oil in other parts. It could freeze up the distributor tubes and you're not getting any flow. Like if you get it so there. So this is why they give a list of the maximum parts per million. So when I worked at Copeland, I think they say about 50 to 75 parts per million. That's the max they want to see. So it's very, very low, I think. And then with other manufacturers, I think I look at Bitzer's, and we can look up in Bitzer's service manager. I think it says 50 to 150, kind of similar to what this one says right here. Depending on what group they come from. I don't know what the group means on these ones right now, but this is the oil, and the oil manufacturer saying this is the max we want to see, or that's gonna start to, I guess, lose lubrication, start to break down the oil. What are some of your thoughts on moisture in a system, Erik? And I know you've definitely seen this in the past before.
Yeah, so I have the most experience with CO2 systems, and every time you introduce water, even in low ppm values, like 200 ppms or something, it will always create an issue, because water and CO2 together will create some acid. That is inevitable. That's just how it works. And again, as Andrew said, every time you have some water in your system, and you have to remember what's the temperatures in your system. We are always below freezing. Nearly always. Liquid lines maybe, of course, be a little bit higher, but as soon as you're on a evaporator side, then you're low temperature. You're below freezing. You're going through small orifices. You're going through your TX valves. You're going through everything. Every time you have a high pressure to a low pressure situation where you have a narrowing path, then you also have an exchange of energy. And you will freeze up that water, and it will block up your valves at some point. You will block up your filters, your strainers, and your valve plates and whatnot. So you don't want any water in your system.
Yeah. And so, the last table here is kind of the acidity. Like, you do not want to be over 0.2 KOH per gram. I did look up what KOH meant. It's the units to measure oil acidity, usually called a total acid number. So a TAN number you might get there. And it's the milligrams of potassium hydroxide per gram of oil. And so a lot of people ask me, well, Trevor, I got this analysis now. Well, how do I actually read it? So I did a bunch of research. And like I said, I'm still learning on it. So here's an example of an oil analysis that the technician sent me. And he said, like, I don't understand how to read it. So what's the first step? Is you start with the analysis section. Okay, right up in the top here, the analysis section. And the first section is moisture parts per million. Now, by weight. Now, you may have different numbers, kind of like I just showed you that one example where it's at 150 or 200 parts per million. And some oils in there said 500 parts per million of water before their oil starts to degrade. This is an example here where I think anything over 100 parts per million is too much. That for me, like, so maybe you might be listening to say, oh, Trevor, you're wrong. I don't, but I think anything over 100 parts per million, that's going to be niche. Even if the oil manufacturer says 200 is okay, I still think that is too much. Just from my days working at the manufacturer, and they're like 50. We build the compressors. We've seen it. Anything over that isn't usually an issue. And even some compressor manufacturers say, oh, 150 is okay, similar to the oil ones. I think over 100 parts per million is considered out of range. This example here says about 105, and you see whoever did this oil analysis say in service limits of 120. So they're like, oh, well, we're okay at 105. And don't get me wrong, it'd probably be totally fine.
It probably will. And you always need to remember what the numbers they write here is in consideration to the oil and not to the rest of the system. So it doesn't take in consideration what happens in your TX valves, what happens in your compressors, what happens wherever. It just is the oil functioning.
Yep, exactly.
Yeah. That is up to you to say, okay, by experience in my trade, I know if I got anything above 100 ppm, for instance, in my system here, then it's too wet. I need to do something about it.
Yeah. And it's not like you have to go in, for this example here, it's not like you would have to go and drain the whole oil and take out 10 gallons of oil. They have filter dryers for that. That's the purpose of these oil filter dryers, to get in and remove that moisture.
Exactly. Yeah.
And then we have down below here the contaminants. So these are metals. And this is the difference between like just doing an acid test and an oil lab analysis, that you can see the metals that are in the oil. And why is this important? Andrew, why do you think this is important to see the amount of metals in that oil?
Well, it first tells you how dirty your oil really is. And as we know, as technicians, we only want oil. We don't want metal shavings flying around inside that compressor. That just doesn't even sound right, just saying it, right? So that's why it's important, because eventually those metals are going to wear the windings out and then cause a direct short or whatever. So yeah, we don't want anything like that at all.
Yeah, and you'll see here, like I did some research and it's funny, I spelled it wrong on this slide. I'll have to, but metal levels are in spec below approximately 20 parts per million, except for phosphorus. So phosphorus is an anti-wear additive in ester oils and should be between 700 and 1,000 parts per million. It may be a little bit different for your oils. You know what I mean? This is something I'm still learning about. But you could see in some of these in-service limits where I say approximately 20 parts per million, they say 7, for aluminum is too much. Or copper, 15. Iron, 10, where I say approximately. So you really want to find out from that specific oil and compressor manufacturer. Because like you said, Andrew, if we start getting more metals in there, that's not good. That is not good. Have you ever seen any high metals, Erik, in systems before in any oil analysis?
Oh, yes. Oh, yes. From different sources and different times in the lifespan of the unit. What you really do not want to see is when you have commissioned a new rack, we always recommend the guys to draw out an oil sample, have it analyzed. Because then you know the state of the unit at the time of the commissioning. And if that sample comes back with a high water content or high metallic contents or whatever it is coming back with, then you know somebody did not do their job correctly. Because then there's something in the assembly process has gone terribly wrong. Either somebody didn't use any protective gas when they solder it, or they didn't clean up after cutting pipes, or whatever happened. So but if it returns, clean, then you also have that as a guarantee to your customer, saying, okay, we have produced a clean system. It has been running now for, let's say, a week or something. Then we draw out the sample, because you need some time to get things, circulating in the system. Make it run for a week or so. Take the oil sample, have it analyzed. Then you see it comes back clean. I say, okay, when I serviced the system, or when I commissioned the system, it was okay. So whatever happens after this, it was not me doing that. It was something happened to the system, or somebody else did something to the system. So that's one reason why I should make an oil analysis. But it could also be, now you have the contents here, the copper and the ions are quite high here. That could also be an indicator for you to say, okay, if I have iron filings in my oil, where do they come from? Where do they come from? Because it have to be coming from some wear component.
Yeah,
but you don't have iron anywhere else, or at least then you have one of your big vessels that are rusty on the inside or something like, so it's not clean proper from the manufacturer.
Yeah,
maybe it had been pressure tested with water and it's not been drained correctly, so it's wet inside. So then you also have a moisture content of 5 million or something. Yeah.
Yeah.
You won't be surprised what we have seen. We are actually one location. We drained the receiver for more than 100 liters of pure water.
Wow. Yeah. That's crazy.
So for two reasons. One reason, it was pressure tested with water from the manufacturer, and the install guys, they have used a CO2 of really, really low quality, so it had a really high CO2 moisture content in the CO2. So everything was just accumulating in the receiver, and we just poured out about 100 liters of water, just flooding out. That was terrible.
Yeah. And I've seen that, and that's not only the way to get moisture in the system as well. Like I've seen on plates breaking and water getting in that way, and different condenser lines breaking and it's raining out, or filling up with water that way. So, like cracking. So there's different ways that it happened, and like this here is the in-service limits. Here's the sample. So this one here was okay on those ones for an example, but reading them super important, and then always follow up with that manufacturer and that specific oil, because this would be from one specific example, right? So they're sampling this similar to the BSE 85K or similar. Down below. Next thing is the viscosity. Really, what's the centi-Stokes? The viscosity of that unit, and I'll kind of read the definition. The unit is in kinematic viscosity. It describes how easily the fluid will flow under gravity at a specific temperature. So higher centi-Stokes means thicker oil, lower centi-Stokes means thinner oil, and that's why in CO2 you will see higher centi-Stokes oil. That's why you'll see the 85 Ks or 68. Koblenz use 68. Bitzer and most all the European manufacturers, I think, is 85. But both can be used in Koblenz.
Yeah, depending on the type. If it's a PAG oil or it's a POE oil, it's a different viscosity you use. And also for the application, if it's a high temperature application, you also need an oil with a higher viscosity.
Yeah,
because it will thin out when it gets hot.
Yeah, exactly. So like a heat pump, for an example, CO2 heat pump, you need to have
a high viscosity oil, but just because you have to compensate for that temperature range it's operating in.
Yeah,
and what so I got super.
Go ahead, David.
What about super high tolerances, like screw compressors? Because I've seen that. I noticed that too when working on screw compressors. They actually have a thicker, I guess, oil. Is that because it's so tight? The tolerances are so tight? Do you know?
I would guess it's about the temperature range of the application, because you have the screws, they are really, really tight together, and you will have a lot of friction heat. You also usually have a oil cooler on screw compressors.
Mm-hmm. Yeah.
Either an active or injection cooling or whatever it is, but you have some kind of cooling system on it. So I would guess it's a high temperature on the screws that dictate that you have to have a different viscosity oil. It's been a few years since I did any screw compressors, but 15 years ago. But that would be the reason.
And then another big one that probably the other most important one is the acidity level. So the KOH per grams is milligram potassium hydroxide per gram oil, which I talked about earlier. You don't really need to understand that, but you need to understand that slide that I showed you before that Giacomo sent me from the REN ISO was 0.2. Okay, KOH per gram. And this one says 1.547. It's like, oh man, like there's a lot of acid in that system. One of the things though about CO2 in the oil is that if the CO2 is present in that oil when that sample is taken, it will give a false acidity read. So I've done a bunch of research, and I had technicians reach out to me and be like, Trevor, I did an acid test. It failed. I did another one because it failed. But guess what? I just did an oil change with all brand new oil. There's no possible way that it should be failing this test because we changed the whole thing. And so doing some research, and they did some research, is that you need to get that CO2 out of that oil before you do that test. Acid test, a lab analysis test or acid test, you need to get the CO2 out. And there was one video that I seen from Sportland and a documentation where they did the tests on because they do sell the acid test, not the lab analysis, maybe to do a lab analysis, but they said heat it to 100 degrees Celsius or 112 Fahrenheit for 10 minutes, or do compressed gas in it for a minute. And that's kind of the video I seen where it's compressing the gas. I should pull it up so the community see. But you need to get that. And it's typical duster, dry air blowing in it. And a tech who took my course, Brad Adams, super smart dude out of California, he was one of the techs that reached out one time, and he was like, Trevor, what I had to do is I had to put it on the oil separator, and I left it on the oil separator because my other test failed. I put it on because and I heated it because that's what they said to do. I did the test again, and it passed that acid test. So just remember, if you're taking these tests with CO2, you want to heat that oil or get that CO2 out of there before you do the test. Because now if you think, man, I'm 1.54, but it's only supposed to be 0.2, we need to do an oil change like right away. Like or do a filter change, you know what I mean? Get some filters, but being that high, I don't think a filter change would do to take that much acid out of the system, because it's like Giacomo said, is like that is super strange. Like it should not be that high.
I think this test you have here is probably done at a laboratory somewhere, and I know the place we use, they always degas the sample before testing it.
Okay.
So they degas it and to take whatever CO2 is left in the oil, remove that before they test the oil. So probably this has been done with the same method, and yep, he had quite a high, in this case he had quite a high moisture content in it, and he had this high moisture content for a long time. Then he goes to build up more and more and more acid.
Yeah. So I'm going to reach back out. I don't know if they did an oil change or not, but I'm going to reach back out to the technicians, because this was like a year ago, and see if they've done a test again and compare it, because that's a good point. Do the lab analysis where they're getting it done. Do they know to degas it first? Things like that. So that's a good point. But this is how you read it, and if you get, and why I keep saying send it to labs for CO2 system. A lot of them here, a lot of people I work with, they're doing larger racks, larger supermarket racks. They're not little condensing units, CO2 condensing units or CO2 systems. Like you're not going to really go and send a $300, I don't even know what it costs, $200 or $300 sample to a lab, and it's a 1 ton or a 2 ton walk-in box. You know what I mean? You can change the oil for less than the amount of that oil test.
Exactly, yeah. Because the big difference is on a big rack, like the racks I've just been on now, they have what is it? It's about 50 or 60 kilos of oil in them.
Yeah.
Yeah. at whatever price it is. But it is not. It is super expensive. It's crazy expensive. So it's much cheaper to just have this oil sample made and have it analyzed, and then come back to the customer and say, okay, I can see. I would suggest we change the oil because I can see these values.
Yeah, and that's a big thing I talk about with a lot of contractors, and I do a lot of these training, like we do a lot of private trainings for contractors, and they got 10, 15, 20 technicians in there, and they like, we struggle with maintenance. It's like our customers don't want to do the maintenance. This is one question I get. We suggest it, we get all this, but they just don't want to do the maintenance. And I say, this is what you can do. You go and do one of these tests. It might cost you $200 or $300. This is a business expense. Okay. But when you bring this and you bring the oil numbers from the manufacturer, you go and show them, this is what the manufacturers, if we're over this means this is going to start to fail. Okay. We're talking, you got 200,000, 300,000, $1 million worth of product. And this is what the test came back, and it fails on 3 points. And it's going to be 10, like you got to do the numbers. It's going to be, 20 liters of oil, the train, you got to do the filters, and you got to do all the stuff, whatever it is. $200,000 of product potential loss, or do a $10,000 oil change. You know what I mean? I don't know the costs anyway, but this is how you talk to your customer. You don't say you need it. You got to show them proof. So they really, because they don't understand. They're like, this is a $10,000 bill. Like, let's just go, let's push it a little longer. But one of those compressors that failed because they didn't be proactive versus reactive is a big deal. And this is ways, maybe you don't need a maintenance contract. Maybe you just got to show them that they need this stuff done.
Exactly. And you can always present them options. When you have empiric data, you can always give him options. Okay, so you can see we have these data here. We show the values. You have this option. We can change all the filters and all that stuff. We will have a stop of 1 day anyways, because we have to stop the unit and vacuum and change filters and blah blah blah. We can change into these, what do you call them, burn-in filters, where we remove the acid and all that stuff. Or we can change the oil and hope that that's going to solve the issue. So you have different options. Yeah. And present what is the consequences of these options. We can let it run and hope that the compressors don't fail at some point. We can use the filters and say, okay, we can maybe save the oil, but again, risk some other components failing, or we can change the oil completely. It would be super expensive, but it's a preventive maintenance.
It won't be more expensive than changing compressor, I bet.
I bet not.
And that's not only one compressor. That could be one fails at that time, but the other 5 are damaged. You know what I mean? Like,
sure, because if one failing on oil failure, you usually also have more coming.
Yeah, and that's the thing. So this is what I want to kind of show you guys in the community today. Just talk about a good conversation, because if you see these numbers, you want to do something about it for your customers to help them out, right? It's to help them out. Oh man,
where would you guys recommend exactly pulling from the oil from where would you pull from the system to send that analysis to from? Separator, compressor?
If it's just a routine check, I'm coming in every half year, 1 year to make my service on it, I would take it from the separator for the oil tank. Do I have any suspicion?
The separator or the reservoir, like the whole?
Yeah, the holding vessel or the separator, one of them.
Okay.
Whatever. See, usually the easiest part is the reservoir, because you can isolate that one and just blow the pressure and take the oil sample and not interfere with the rest of the system. But if you have a suspicion, say, okay, you have a bad sounding compressor, or you have previously encountered higher levels on your oil samples, then I would pull the oil sample directly from the compressors.
Yeah, that's a good idea. Yeah. Because that oil
from the lead compressor, because that's the one with the majority of the hours.
Yeah, because that's getting more oil through it, and getting more oil to it versus the one on number 4 or 6 down the line that might only run 1,000 hours a year versus 8,000 a year or whatever, you know what I mean? So that's a very good point. Because that one that's sounding bad, the oil in the bottom of the sump may be a little bit different than what's actually coming out of that reservoir. I love it. That's super helpful. Any final thoughts for the community, Andrew?
Just if you got questions, ask on the community. That's what we're here for. And help in any situation. I think we did a really good job of explaining why it's important and what we talked about today, which is great. But yeah, I mean, just don't be afraid to ask questions, because I guarantee if you have that question, there's going to be other people have that same exact question. So that would be where I will end that.
Yeah, and keep yourself updated on the equipment you have and the equipment you are working for. It could be that your company is switching over to a new product line of a service, maybe let's say CO2 systems. You have never worked on CO2 system before. Reach out to your manager and ask if you can be sent to a factory class, for instance, to get some proper training on that equipment.
Yeah, I think that's super important too. Like the more training, the better. Like we do training consistently, CO2 training every month. We'll be doing private training or individual training, but you still got to do more. You got to go to the manufacturer training. You got to go to a wholesaler if they're having training. The more you do, it just brings you more value. You can go and sit and go watch the football game or the soccer game or the hockey game. It's great. You can do that stuff. But if you're not happy where you're at, and if you're worried about it, you go and invest in yourself. That's it. Invest in yourself to get you to where you want to be. You got to make a little bit of sacrifice maybe now to benefit your future self. And I say this all the time. Future Trevor is going to be really happy about what I'm doing today, even though it sucks what I'm doing today, potentially. You know what I mean? But it'll be that much better in the future. Guys, I want to thank you so much for sharing some of the knowledge, our conversation on talking about what's going on a bit in the industry, and then getting into kind of some of this technical stuff, this oil analysis. It's super important. A lot of people miss this. A lot of people are like, oh, I did just an acid test and I passed the acid test. But it doesn't mean there's other stuff going on. It doesn't mean that the rings on one of those compressors are wearing because you're not getting the proper lubrication to it and it keeps tripping off. You know what I mean? That's the metal test like Erik was talking about. You get a lot of iron in there. Well, where's the iron coming from? So that's one of the things. So I want to thank you all so much. And those listening out there, if you're interested in learning more from Andrew, or learning more from Erik or the community, head to refrigerationmentor.com/hub and check it out, because we're here to help you grow and help us grow. Guys, thank you so much for taking the time, and we'll see you again at the next meetup.